And the graph of a quadratic function is the shape of a parabola. The leading coefficient a determines the direction of the parabola.
So this is all about that if the quadratic function, what I mean to say, if the degree is 2, the second degree function. So
Right.
we were plotting that, we were talking about the leading coefficient that is just describing its shape. Either it is upward or downward, leftward and rightward, and then that was actually parabola. So whenever there is a quadratic function, so the degree is square, that is the quadratic function having degree 2, and that can be written in the what we can say in the general form, that is f of x is ax square plus bx plus c. A, b, c are real numbers, and we have already solved the quadratic equation of these types. Anyhow, we will see this. So here we can see the actual shape. If a is greater than, that was the leading coefficient, the parabola opens upward, just like this. For example,
Okay.
fx is equal to x square. So a is 1 over here, that is positive. So that's why this can be represented upward open. The minimum point on a parabola opening upward is called the vertex. So this is called the vertex, where it is meeting the x-axis or meeting somewhere. So that point is
Okay.
called the vertex. If it is less than 1, so the second diagram is talking about when a is negative, then the parabola opens downward. For example, fx, and this is minus 1 over here. So this negative sign is clearly showing that this is the leading coefficient a, which is negative. The maximum point on a parabola opening downward was called the vertex. Now this is the maximum point, so it is the maximum height, it is coming down, and this is the vertex, and here the vertex is this. So from these two diagrams, we will have to look at this. If the fx is equal to x square is 1, 1 is greater than 0, and if negative sign is there, so there is a minus 1, so that is less than 0. So we can draw these two types of the parabolas, and vertex is this point where it is touching on the x-axis. Anyhow, quadratic function, it is important to notice that the graphs of the constant functions and linear functions are always straight lines. So uh, linear functions, linear equations, those are representing the straight lines. We have already said that the quadratic function is a polynomial of degree 2. So quadratic degree is 2. Here are some examples of quadratic function. So we have already talked about this, that f of x is equal to x square, f of x to x square. Here the leading coefficient is plus 2, so this will be open upward. And once again, 5x square. So these are the types of quadratic functions. So each and every function is representing a parabolic shape, either downward or upward. So whatsoever is that, so the main thing is that the degree of the variable must be 2. So that's why these are called quadratic functions. So I'm sure that you are getting this.
Yeah.
Okay, now let's see. So quadratic function, we have so many shapes because these shapes openly upward, and these are different shapes. Now you can see fx, this is the first most, what we can say, the curve that is fx is equal to what we can say fx 5x square. So 5x
Right.
square is representing this parabola, and once again we have fx is equal to x square. So this is slightly wider than the previous one, and at the end the third one is this one. So this is fx is equal to x square. So from here we can draw each and every parabola by tracing its points according to the equations. So we can get the both the end, the left hand and the right hand, just like that. So anyhow, these are all the parabolic functions. These are all the quadratic functions, and they are representing the curves which are parabolic and openly upward because each and every leading coefficient is positive. So here,
Okay.
the next example is the same functions. They have the same, just only difference is that they have the negative coefficient. What I mean to say, the leading coefficient that was a. So this time -1, -2, and -5. So each and everything will remain the same. The main difference is that they are opening downward. So once again, we can start from this -5x square, the most inner one, then the third one, second one is -2x square, the last one is -x square. So all these are opening downwards. So from here,
Right.
from these two diagrams, we can easily determine the shape of the parabola whatsoever the function is given. So we will have to take notice of this. If there is a negative sign, so this will open downward. And if there is a positive sign, they will open upward. But anyhow, we can trace just putting the values of x and y, making some table and tracing all those values and joining those points will get the exact shape. But anyhow, this is a major characteristics. When we have a negative, then leading coefficient is negative, then this will be opening downward. And if the leading coefficient is positive over here, so this will be open, what we can say upward open. Anyhow,
Right.
exercise is this, you can just take the screenshot, identify each function as a linear, constant, quadratic, or none of these. So here, this one is a constant function because only the constant is there. And from here, we can say this is a quadratic function. We can trace, we can get the shape, and the leading coefficient is positive, so that's why it will be open upward. And once again, this is a linear function because the maximum degree of the variable is 1. So here we have this one, but this is once again a linear function. So from these examples, we can say that this one is a quadratic function because the degree, the maximum power of a variable is 2. That's why it's a second degree function, and second degree is always called the quadratic function. And if we are going to draw this, so this will open upward. We will have to put the values of x just to get the values of y. And from there, we can get the coordinates of any point. And we can join those points and we'll draw those. And this is for the exercise. You can trace all these functions anyhow, and you can also share with me. Okay.
Okay.
Now let's see the next is solution of the previous. So I was talking about that, this is a constant function. So here we have -4, and this is a quadratic function as we were talking about that. So a is not equal to 0. So upward. This is a linear function, and this is also linear, and each and everything is also written. So you can also take the screenshot of this just to rematch your answers. But anyhow, these are very simple. There is nothing very special in this. So we are just moving to the next slide. So next part is the x-intercept and y-intercept of the function. So when we have a function, so definitely that parabolic lines, they are intercepting the axis. So we will have to check their point of interception with the x-axis as well as with the y-axis. So x and y intercepts of a function. Finding the x and y intercept of a function defined by y is equal to fx to find, because sometimes the function is given either that is in the graphical form, which is being used over there in the delta math site, or either it can be given as in the shape of equation, and you are just asked to find the y and intercept, y and x intercept. So to find, so that's why this is the working rule. To find an x intercept, we substitute y is equal to 0. and solve the equation for x. Using the function notation, this is equivalent to finding the real solutions of the equation fx is equal to 0. So once again, I'm repeating for you that if you are looking for the x-intercept, put the value y is equal to 0 or the given function fx is equal to 0 and solve for x. So the value of x, that will be the point where it will intercept the yx. And in this way, we can find the x-intercept. X-intercept is the height. What we can say, that is the point from the origin to the x-axis, either on the left or the right, according to the values. And in this way, we can find the x-intercept. Similarly, if you are looking for the y-intercept of any function, so what we'll have to do, put the x is equal to 0 and solve the equation for y. In function notation, this is equivalent to f of 0. So fx 0, so we are putting x is equal to 0. So in that function, whatsoever the function is, we are replacing each and every x with 0, so we'll get the y-intercept. And if we are looking for the x-intercept, we will have to put that function equal to 0 and solve for the x. Are you getting this?
Yeah.
So it's very simple. Lot of questions are given, lot of graphs are given over there in the delta math sites. So from there, you can look at the graph and the equation is given. So if you are looking for the x-intercept, so put that function, that equation equal to 0. And other way, if you are looking for the y-intercept, so what you will have to do, replace each and every x with 0 of the given equation of the given function. So you will get the values of y, and that will be the y-intercept. I'm sure this working rule is enough to find out the x and y-intercept, isn't it?
Yeah.
Okay.
Yeah.
So you must try in your own time that if they are asking about the x-intercept and y-intercept, so you will have to follow these 2 points. So anyhow, I will send you all these slides. So by the time you can, if you are missing something, so you can also read these and you can recall all this. Anyhow,
Right.
the next is that functions in mathematics, finding the x and y-intercept of a function. So let's see, given a function defined by y is equal to fx, so we are taking the general format of the function that y is equal to f of x. The x-intercept are the real solution to the equation fx is equal to 0. So whatsoever the equation is given, so you will have to put that function equal to 0. The y-intercept is given by that f of y f of 0. So you will have to replace each and every x with 0. Example is finding the x and y-intercept of a function given the function defined by, so this time f of x is given, that is 2x minus 4. Find the x-intercept. So we will have to put it equal to 0, and the y-intercept, we will have to replace each and every x with 0. So graph the function, and we can graph also, just tabulating some values for x and y, getting the coordinates of the different points. At least there must be 3 points, then we will be in a better position to find the graph. So I am
Right.
sure that you can solve this. But anyhow, look at the solution. So this solution is for you, just solution of the previous example to find the x-intercepts, find the real solution to the equation fx is equal to 0. So we are putting this function that was given. We are putting it equal to 0. Look at this, left hand side is replaced by 0 and right hand side as it is. So what we are doing over here, so x is equal to 2. The x-intercept is 2. So from here, you can count from 0, that is the origin, and on the graph paper, if you are taking the scale appropriate to your length, that 1 square is counting the 1 unit. So we are 2 unit away from the origin on the x-axis. So this will be the y-intercept, x-intercept. So this function is going upward, but I mean to say its slope is positive. And one more thing is that it is crossing the x-axis at 2, where the y is 0. So x-intercept is this one, and its slope is positive, that is 2, and it is going in this way, tilting right and going up and up. So it's also increasing function. So if this type of the graph is given and you are asked to find, so this point is very easily. And here, this is also crossing the y-axis, but that is below the 0, below the origin. So it will intercept the y-axis minus 4. And we can find that also by using that formula to find the y-intercept. Evaluate f at 0. What I mean to say that each and every x in the given function must be replaced with 0. So in this way, to find the y-intercept, f0 is that we are replacing each and every x is equal to 0. So with 0, 2, minus 4, f0 is minus 4. The y-intercept is 0, minus 4. So this is the point where it is intercepting the y-axis uh, down the origin, and it is a minus 4. So you can see that if the graph is given, you can find the x-intercept as well as the y-intercept and the slope of 2. So slope is 2, because if we are just comparing this, that y is equal to mx plus c, so c is negative, m is positive, so mx means the slope of the function. I'm sure that you are with me.
Yeah.
Okay. So this is the way to get the intercepts. So slightly different. When you are looking for the x-intercept, put the whole equation, the function equal to 0. If you are looking for the y-intercept, just replace each and every x with 0. Okay.
Okay.
So in short word, we can say just like that. So one more example is that find the x and y-intercept of a function. For the function pictured in 1.1, this is the picture as estimate the real value of x for which fx is equal to 0. So the value of f at 0. So in other way, what we can say that you are looking for the x-intercept and the y-intercept. So if you are putting the values, so you can see this is the y-intercept, because this curve is intercepting the y-axis at this point. And similarly, it is touching over here on the left hand side and touching twice on the right hand side. So solution, look at the solution. The real value of x for which fx is equal to 0 are the x-intercept of the function for this graph. The x-intercepts are located at x is equal to minus 2. Look at this. This is minus 2. X is equal to 2. So once again, it's touching the axis on the right hand side, that is 2, and also touching, coming down and then going up. So at 3. So there are 3 intercepts, x-intercept. These are minus 2 on the left. You can see that x is equal to 2, that is positive on the right side. And once again, x is 3. So if this function is given, this graph is given, and you are asked to find. So what you will have to do, you will have to observe all those points which are at which the curve is touching the x-axis, as well as what I mean to say on the left hand side and right hand side. So this is what we can say, that the easy way to find out the intercepts. So the next is that is the y-intercept. Now we are looking for the y-intercept. The value of f at 0 is the value of y at x equal to 0. That is f0 is the y-intercept. So fy is 6. So here you can see that this curve is touching or crossing the y-axis at 6. You can see the value 6. So only y-intercept touching once on the y-axis, crossing one, intercepting y-axis at a single point. That's why it's a 6. 6 is the y-intercept. So skill practice, use of function practice below, estimate the real values of x for which f is equal to 0. You can see from here, estimate the value of f0. So if you are given, and these type of functions are given also on those screenshots, and so it's just a reminder that please send the other topics also that I should come out with those
Okay.
solutions. So I'm sure that now your cell phone is all right, and you can also.
Yeah, now it got repaired. Yeah.
Okay, okay. So keep on sending other topics of your study. So I think now your classes are online or you're going to school?
We were going to school, but now we switched back to online.
Okay, okay. So same is the condition over here. Anyhow, so this curve is crossing 3 times the x-axis. So there are 3 your x-intercepts and it is touching the y-axis only once. So we can get the y-intercept from here. Anyhow, this was so simple. So we are just moving to the polynomial function. So polynomial function and quadratic function, we will find that what we can say the difference. A polynomial function of degree n in the variable x is the function defined by this way. So this is the general format of any polynomial function because there are so many terms. So starting from the coefficients and raising to the power x, and these powers are decreasing now, and at the end we are reaching at the constant. Where each a is real and a n must not be equal to 0 and n is a whole number. So an is called the leading coefficient. So this first is the leading coefficient and that will determine the shape of the parabolic curve. N is the degree of the polynomial. So starting from the highest degree and it's a decreasing on the preceding, what we can say on the further terms. And a
Right.
naught is called the constant term. So this will be when x having n minus n, so that is 0, and we will have a constant term only over here. So a lot of terms are involved over here, so that's why it is called polynomial function. So from here we
Okay.
can see some characteristics over there. Let's see, remember integers are -2, -1, 0, 1, 2. Now decimals are fractions. So positive integer would be 0, 1, 2. The polynomial function is a function of the form fx. So a n x n. And here you can see the degree is decreasing by 1. And it's going on. And
Right.
from here you can see all of these coefficients are real and real numbers. But I mean to say a n is a real number, a n minus 1 is a real number, and this will go on and reaching at the constant term. So n must be positive integer and these coefficient must be the real numbers. The degree of the polynomial is the largest power on any x term in the polynomial. So we will have to check the variable and we will have to find the highest power of that variable. If that is 2, it's a quadratic, 3, 4, 5, and so on. So this will define or this will decide the degree of the function. Polynomial function having degree 2, 3, 4, 5, or whatsoever. The next is example of polynomial. So look at these functions. Find the leading coefficient and degree of each of the following. So can you read this?
Sure. F of x is equal polynomial function is f of x is equal to -2 2x to the 5th power plus 3x to the 3rd power -5 is, sorry, -5 plus 1. Uh, my screen's a little blurry. I don't know if you, could you like read the rest or maybe like
Okay,
a
okay,
little
okay,
bit?
okay, okay.
Yeah.
Okay, anyhow, fx is -2x5 plus 3x cube minus 5x plus 1. So it's a -2. -2 is the leading coefficient. And degree is, the maximum power is degree. So it's a 5. So degree is 5. In the second function, fx is equal to x cube plus 6x squared minus x plus 7. So leading coefficient is 1 over here. So leading coefficient is 1 and degree is 3. The last function is, that is fx is equal to 14. So leading coefficient is 14. The degree is 0 because there is no x. So this is all about the example with the explanation. So
Okay.
polynomial function, we can see this, this is a linear one. You can see this is a linear. The degree is 1 because x having power 1. It's a linear. It's a quadratic because its a degree is 2. So degree is 2, quadratic, and cubic. Its a degree is 3. So this function has cubic. Quadratic function that having degree 4. The largest exponent within the polynomial determines the degree of the polynomial. So I'm sure that now degree of any function is clear to you.
Yeah.
So degree is the highest exponent of the variable, or highest power of the variable, whatsoever the variable is. Here this is 1, here power is 2 and 3 and 4. So this is all about the degree and the types of the polynomial functions. So graph of the polynomial functions are continuous. That's they have no breaks, holes or gaps. So polynomial function fx is equal to x cube minus 5x square plus 4x plus 4. So continuous smooth polynomial. Not continuous, this is discontinuous because there is a break. And continuous, not smooth, not polynomial. So it's not smooth going zigzag, but it's coming and going down and up. It's a smooth. Polynomial functions are also smooth with rounded terms. Graphs with points are cusps are not graph of polynomial function. So these are not the polynomial function. The other is that polynomial functions are smooth. They have the curve at the bending points, but here we can find no curve. They are just breaking and joining together. So not smooth. Polynomial
Okay.
functions of the form xn n1 are called power functions because you can look at this fx equal to 4. So you can draw this fx here is equal to this black one. And similarly, these are n is even, their graph resemble the graph of fx. When x is even, so these are symmetrical. What I mean to say, these are just like that. And if n is odd, so look at this odd function. So this is just like that. If n is odd, their graphs resemble the graph of fx. So from here we can say, look at this, sketch the graph fx is equal to minus x plus 2 whole power 4. This is a shift of graph y is equal to x minus 4, 2 units to the left, 2 units to the left. In turn, is the reflection of the graph y is equal to x4 in the x-axis. So you can see just like that, if function is given y is equal to x4, so you can draw this parabola. And if it is what we can say plus 2, so it's a shifting. What I mean to say, y is equal to minus x4. So if the leading coefficient is minus, so this will be the downward opening. Are you getting this? Why it is downward?
Yeah.
Because the leading
Right.
coefficient is negative. If the leading coefficient is positive, then it is upward. But this is what we can say, slightly moving 2 units from the origin, 1 and 2, touching this one. So that's why it is what we can say negative. Look at this negative. So negative means that it must be open downward. and 2 units from the origin. So 2 unit from the origin. So this will be 2 unit, 1 and 2, and coming down. Polynomial function f(x) will 3 constant function degree 0, maximum number of zeros. So it's a constant function. F(x) is equal to 3 because there is no variable, so degree is 0. Maximum number of zeros 0. Maximum number of zeros 0 because whatsoever it will touch at any point on the y-axis or this, look at this. So only one once it is touching the 0 at the origin.
Right.
Look at this. So similarly, polynomial function is f(x) x plus 2. This is x plus 2. Linear function, this is a linear. Degree is 1 because the exponent of x is 1. Maximum number of zeros 1 because it will touch the y-axis or the x-axis at only one point. So there it will get the x is 0 and here it will get the y is 0. So it will get 0 ones over here and here. So that's why maximum number of 0 is 1. So polynomial function, another example is given that f(x) is equal to x square plus 3x plus 2. This is the quadratic function. Quadratic function degree is 2 because from here we can decide the degree.
Yeah.
That if x has power 2, so this will become second degree. Maximum number of zeros. Maximum number of zeros, if you are just going to factorize these, so you will get 2 factors, and when you are putting those 2 factors equal to 0, so you will get 2 zeros. So look at this, that this is touching over here and also touching over here and here. So if you are looking for the x values, so this will touch the x-axis over here where y is 0, and once again it is coming down and going up, so it will touch the x-axis at -2 also. So here we can say that we have 2 zeros for y. Twice the y is becoming 0. Are you getting this?
Yeah.
Okay. So sometimes only the graph is given and you are asked to find the number of maximum 0, and you are asked to find the degree because it's a parabola, parabolic shape. You can state with say it's degree 2. It is touching the axis twice. So you can say the number of zeros 2. Look at this. Polynomial function x cube plus 4x square plus 2. F of x is equal to x cube plus 4x square plus 2. Now the maximum degree is 3. So cubic function degree is 3. Maximum number of zeros 3. So 3 in the sense that if you will solve this, so you will get 3 vectors because it's the cubic, and those you can put those vectors equal to 0. So that's why it must have 3 zeros. 3 zeros. Maximum number of zeros, it will have 3 zeros. So polynomial biquadratic equation. Biquadratic mean quadratic. Quadratic mean that it must have 4 degree. So degree is 4. Maximum number of zeros 4. If you are putting x equal to 0, so you will get the 4 factors. So twice on the left hand side of origin on the negative x-axis and twice on the positive x-axis. So in this way, you can get the number of zeros. So leading coefficient. So we will talk about the leading coefficient. Leading coefficient test as x grows positively or negatively without bound. The value of x of the polynomial function, just look at this, grows positively or negatively without bound depending upon the signs of the leading coefficient an. First, this one, the coefficient of the highest degree,
Right.
and whether the degree n is odd or even. So we will have to look at this. So n is odd, the function is just like that.
Okay.
an is positive, so that's why it is going upward. An negative, so this will be just like that, and this is positive, so this will remain upward. It will go upward when the leading coefficient is positive. So you will have to draw the upward opening, going upward.
Okay.
If you have the n is negative, so it's a downward. Look at this, n is negative, so its opening is downward. And at the end, it will go down and down on the both sides. So describe the right hand and left hand behavior for the graph fx minus 2x cube plus 5x square minus x plus. Degree is 3, so degree is odd. Leading coefficient is 2, but it's a negative with a negative sign. So this will be just like that. So it's a coming down. Look at this. And it is also curved in this way. And then it will go on the other side. So a real number is a zero of function y is equal to fx if and only if f is equal to f of a is 0. A real number a is 0. If we are putting that for that value, function is equal to 0. Real 0 of polynomial functions, if y is equal to fx is a polynomial function is given and a is a real number, then the following statements are equivalent. A is a 0 of f. So sometime the graph is given and we are looking for the zeros of that function. So what we'll have to do, we will have to replace each and every x with 0. And if this function is equal to just like that, that putting the value of that a is a 0 of f. So a is a solution of the polynomial function equation fx is equal to 0. When we
0.
are putting this equal to 0, then we'll have to solve this and we'll get two values or one value, whatsoever the case is, that is a. So x minus a is a factor of the polynomial fx. So x is over 0, a, x is a and y is 0, then x-intercept of the graph. So a turning point of a graph of function is a point at which the graph changes from increasing to decreasing or vice versa, or decreasing to increasing. A polynomial function of degree n has at most n minus 1 turning points and at most n zeros. So degree will define, a degree of a function will decide that how many turning points, one less than the degree, and how many zeros, that is equivalent to the degree. So if the function is given and you are asked to find the number of zeros, so if it has 3 degree, so it must have 3 zeros. If it is quadratic, that is having degree 2, then it must have 2 zeros. And if it has cubic equation, so the degree is 3 now, so it must have 3 zeros. In other words, if you are looking for the turning points, so you will have to one less than the degree of the equation. If the equation is quadratic, so its degree is 2, so 2 minus 1, 1. So it must have 1 point, turning point. And turning point is a point from where it is changing its course of motion. If it is increasing and at that point it is becoming decreasing, or if it is a decreasing and all of a sudden it is going to up, increasing. So linear function, so what is the turning point of a linear function? Question is for you.
Oh,
Hello. If
yeah.
function is linear, so how many turning points?
If it's linear, that means it's 2. So n minus 1 would be 1.
Linear function having degree 1, I am not talking about the quadratic function. What is the degree of a linear function?
Linear is 2, right?
2 is
Or no, that's
quadratic.
quadratic. Yeah, no, wait. Linear is, what do you call it?
1.
1.
So 1
Yeah.
minus 1,
So it'd be
0.
0. Wait, you can have a 0?
Why 0 is a turning point because linear line is never turning. It is going upward or downward straight way. Linear
Oh, okay,
equation
so
representing
that's
a
what,
straight line.
yeah, okay.
That's why there is no turning point. Because turning point is defined as that the x and n minus 1, when it is a degree 1, so 1 minus 1 is 0. So 0 is the turning point because here we are what we are saying that the degree is, if you can see the last line, please read this one if you can read this line.
Sure. A polynomial function of degree n at most n minus 1 is turning points and at most n zeros.
So n is the degree. So linear function has degree 1, quadratic function has degree 2. So that's why linear function has no turning point because 1 minus 1 is 0. And it has degree 1, so it has maximum 1, 0. So turning points of polynomial function, the turning point of a function is a point. Please read this one just to get the understanding. Please.
Sure. So a turning point of a function is a point to where the graph of the function changes from sloping downwards to sloping upwards or vice versa. So the gradient changes from negative to positive or from positive to negative. Generally speaking, the curves of a degree n can have up to n minus 1 turning points.
So for instance, a quadratic has only one turning point because it's coming down and it's a turning point now, it's going up. So by looking the graphs, you can talk about the degree of the functions and the turning point and the number of zeros. So if you're looking at the graph and if the graph has 3 turning points, that the at 3 points it's changing its behavior. Sometimes it is going up, down, and then down and up. So if it has 3 turning points, then you must say that this is the degree 4. The function of the degree of the function is 4. If it has 2 turning points, so you must say that is a cubic equation. If it has 1 turning point, as you can see in the diagram now, so you must say it's a quadratic equation. If it has no turning point, then immediately you must say that it is a straight line. And straight line is never turning anywhere. It's going either upward straight way or downward straight. So no turning point because
Okay.
degree is 1. So this is all about that when you will go and look back all those diagrams. So they are asking about the turning points, the number of zeros and this and that. And number of zeros is equal to the degree of the function. Now, as you can see, this is a parabola. It has a degree 2. It's a quadratic equation. So it must have 2 zeros. 2 zeros. So anyhow,
Right.
so this once again, this is the example. Look at this. Find all the real zeros and turning points of the graph. For example, fx is equal to x4 minus x cube minus 2x. Now look at the degree. Factor completing. So we are just factorizing this. So the real zeros are x is equal to minus 1. We can put each and every factor is equal to 0. So we'll get x is equal to minus 1, x is equal to 2, and x is equal to 0. So from here, x is equal to minus 1, x is 0, and x is 2. So these are the real zeros. So how can we find the real zeros? So turning points. There are 3 turning points. It's coming down and going up. There's a turning point coming down. And once again, it is a turning point. There are 3 turning points because the maximum degree of the function is 4. So 4 minus 1, 3. The corresponding to the x-intercept, these are the intercepts. And the graph shows that there are 3 turning points. Since the degree is 4, this is the maximum number possible. So are you getting this example? Is there any confusion?
Yeah, okay, now I get it. Yeah, fully.
Okay, so the it's a 4-degree having 3 turning points and 3, what I mean to say, the real zeros. Real zeros are the vectors. So twice 0 because x square is equal to 0, so you will get x is equal to 0.
Okay.
Now find the real zeros of this function. We will have to factorize. So we'll get this, and these are the real zeros. So find out the real zero means that what you will have to do, you will have to factorize that and put each and every factor is equal to 0. You will get the corresponding points. So here x is equal to 0. So this is the point. This is the point origin, and it is the what we can say real zeros. So repeated zeros, if k is the largest integer for x minus k is a factor of fx, k is greater than 1, then a is a repeated zero of multiplicity k. If k is odd, then graph of the fx crosses the x-axis at a0. Even if and a k is even, touches but does not cross the graph at the x-axis. So you can see this. Determine the multiplicity of the zeros. So just like that, zeros 2 because we have 2 factors. So odd is the power. Multiplicity 3 odd. Behavior cross x-axis at 0, 1, and this is -1. 4 is even and touches x-axis at this point. So you can see this one. So these are the examples. You can solve these because it's very simple. You can take the screenshot. Otherwise, I will send all these slides. So I think
Okay.
it's all about that for 2 days. And in the next, we will talk about the last type of the function, that is the exponential function. And we'll also talk about the trigonometric function, and this will be the end. So I'm sure that after going all these lessons, you will be in a better position to solve all those graphs which are given to you. So thank you very much for joining today. Anyhow, it's, if anything you want to ask or want to share.
I don't think so. I think I got
Okay.
most of
Okay.
it.
So you
written
must send the
down.
screenshot of the other topics.
Okay, I will.
Okay. Allah Hafiz.
All right, Allah Hafiz.